Okay, right. Today we're going to be looking at formulae and functions. And our first question here, I'm going to let you have a go at just the statement and this statement and see how you get on. Then we'll look at the next question. I'm going to give you about a minute just to read through that and have a go. Right, okay, so Gene says squaring any number greater than 0 always gives an answer greater than doubling the same integer. From which of these values is Gene's statement true? 0.5, if we square that, we get 0.25. And if we double it, we get 1. So squaring does not double it, so we won't tick that. 3 squared is 9, and if we double that, we get 6. So that is true. And 6 squared is 36, double that, we get 12, so that's true too. If n is a positive number, what is the range of values for which Gene's statement is true? Now you should have realized that it must be n is greater than 2. Okay, because if you double 2, you get 4. If you square 2, you get 4. So that's the point at where they're equal to each other. For anything less than that, you double it, it will be greater than the square. Right, let's just think about this. I want to give you 30 seconds to think about that and see if you can come up with a value that disproves their statement at the end here. My hint is to think about factors. Right, so as I said, we need to think about factors. It's the easiest way to look at this. Because if you have a common factor for all of the things, then you know you've got a number that goes into it, and therefore it's not going to be prime. So if we've got 5, x equals 5, then you've got 5 squared plus 5 plus 5, and you can clearly see a common factor of 5. You make x equal to 5, and 5 is a factor of this bit, 5 is a factor of that bit, and 5 is a factor of that bit. And you can see you've got a number which disproves this statement. Is it the smallest number? Well, let's just check 1, that gives us 7. 2 gives you 4, 6 is 11, 3, 9, 12, 17, 4, 16, 20, 25. So 5 isn't the smallest number, but it is a number, so it's always an easy number, and it's worth checking the lower numbers. And 4 is actually 4 squared 16 plus 4 plus 5 gives you 25, which is clearly not a prime number, as 5, 25 and 1 all go into it. Right, let's do some functions work. Okay, if you've got these functions, I'm just going to give you 30 seconds to try and do the first one and then go through it, and similarly for each one. I'm going to give you 30 seconds on each. Most of these should be doable in 30 seconds. Let's have a go at the first one. here we go. So this is a sort of question which does upset level 6-7 students quite a bit. And what it means is you here fg of x means you basically need to know what g of x is and put it into f. So we're going to get g of x, which is x squared plus 1, and we're going to put it into f. So fg of x is equal to f of x squared, and this is acting up a little bit. Just give me a second, I'm just going to close this down and start it again. So there we go, x squared plus 1, and what we do is we put that where the x would be in the f, so it goes into there. So f of x squared plus 1 means we need to times that by 6, so 6 times x squared plus 1, then add the 9. So we've put that into the f. So we get 6 times x squared. 6 times 1 is 6 plus 9 gives me 15. Right, let's give you 30 seconds to have a go at the next one, gf of x. Okay, so same again. We're going to take, this time we've got f of x and we're putting it into g. So we've got g and we're going to put f of x into that. So doing g of 6x plus 9. And that equals, now if we take 6x plus 9 and put it in where the x is in g, then we're going to end up having to square that. So we get 6x plus 9 all squared plus 1. And I don't think it's going to make it any simpler, but we can square this out. So remember, when you do square it out, it means 6x plus 9 times 6x plus 9, and then add on the 1. 6x plus 6x is 36x squared, and then we're going to get a 9 times 6, 54, another 9 times 6 is another 54x, and we times both of those out. Sorry, I'm trying to get it into too small space. That's 54x plus 9 times 9 is 81 plus 1. So you could write it out 36x squared plus 108. Sorry again. 108x plus 82. Now, if you know 30 seconds, to try and work out the inverse function. See if you can remember what the inverse function is. It will only take 30 seconds if you do. Right, so we're going to do inverse function of f. Now there's two ways to do it. You could draw a flow chart. Times by 6 get 6x, plus 9 get 6x plus 9. This is the simple way to do it. And then you start off with x and you undo all those things. You take away 9, so x minus 9. Then you divide by 6 and you get x minus 9 over 6 is one way to do it. So that would be my inverse function. Now that doesn't always work. It works for simple ones like this, but it doesn't always work. If you let y equals 6x plus 9 and then make x the subject, this always works. So we do y minus 9 equals 6x, take away 9 from both sides and divide by 6, you get y minus 9 over 6 equals x. But that isn't the inverse function, it just tells us how to get it. So what I'm going to do is take this bit and replace it with x. And we get x minus 9 over 6, just like we did up here. So you can see both methods give you exactly the same answer. But remember, it's f minus 1 of x, so x must be in the inverse function when you finish. Okay, this works for nice simple ones. This will work for much more difficult ones where you've got x's in more than one place. So if you just got x in one place, then use a flowchart. Otherwise, you have to use this method. Okay, 30 seconds to do f of x. Right, so f of x. So we're going to take 6x plus 9 and we're going to do f of it again. So we're going to do f of 6x plus 9. So that means we're going to put 6x plus 9 everywhere where the x is. So we do that again. So that was equal to 6 and then 6x plus 9 again. So 6 times 6x is 36x. 6 times 9 is 54 plus 9 is 63. Let's just check you know how to put numbers in. See if you can do both of these. I'll give you 30 seconds for both, because all you're doing is just putting a number into answers we've already worked out. Okay, so we've got fg of 1, so we put 1 into f of g. So we do 1 squared is 1, times 6 is 6, plus 15 is 21. Nice and easy. Fg of 9, then what we got? We've got 6 times 9 plus 9 is the same as 7 times 9, which gives us 63, and we want to do 63 squared, which is probably a bit tricky for most. So you can use your calculator, 63 squared, and then we've got to add on 63 squared plus 1. Notice I've used this version here, okay, the 6x squared plus 9 plus 1, rather than this version here, rather than going to this one, because it's going to be simpler to work out the answer. And you get 3,970. Right, moving on. Let's just change the view on this to that. And what we're going to do here is we've got a proof, and your proof is made up of this list of statements, and you've got to try and put them in the order. So just try and work out which one you're going to put first, then second, then third, then fourth, and I'll just number them 1 to 4. I'm going to give you 30 seconds to see if you can work out what order they go in. Right, So sum of the squares of two consecutive even numbers of multiple of 4. So we got to use the sum of two consecutive even numbers. Now this one actually gives me some odd numbers, two odd numbers. That's one odd number, and this is the next odd number along. Because you times something by 2 guarantees it's even, then add 1 makes it odd. So this is not what we're going to use. So we're going to use the 2n plus 1, 2n squared plus 2n plus 2 squared as my two consecutive even numbers. So that's what they are. We know 2n is even. Square it gives you even number squared. 2n plus 2 is the next even number. It's got to be 2 more. And we square that. And then what we do is we multiply that out. And we can see we haven't got the multiplying out of that. So we get 2n squared, we get 4n squared. And 2n squared plus 2 is going to give me another 4n squared. 2 times 2n is another 4n. Plus another 2 times n is another 4n. Plus another 4. And we can see we have got 8n squared plus 8n plus 4. So that's our first thing we need. Then we need that, and then we need to factorize, and we can take out a factor of 4 because we want to show it's a multiple of 4. And once we factorize, we get this must be a multiple of 4 because we know this is an integer, because we know that 2n squared was because we know we put the because n was an integer. Okay, if n's an integer, that's what we assumed, then we've got even numbers. Okay, so moving on, try and do this one. I'm going to give a bit longer on this one. Just realised I needed to grab some of these and bring them down. Copy, because you're missing some of them. There we go. So it was meant to be from the whole list. I'm going to give you another 30 seconds, see if that helps. Right, so here we go. We want two consecutive odd numbers squared. Well, there's one odd number. Here's one odd number squared, and here's another odd number squared. So that's number 1. That's where we start with. And we want to square that out. So we need to find out where that's multiplied out. And here is where it's multiplied out. 4n squared plus 12n plus 9 is this squared. And 4n squared plus 4n plus 1 is this squared. So this is number 2. And then we combine these, so we get 8n squared plus 16n plus 10. So there's number 3. Now we want to try and take out a factor of 4. And I think this is where we do it. We get 4 times 2n squared gives me the 8n squared. 4 times 4n is 16. 4 times 2 is 8, but there's a 2 left over. So this is part 4. Now because this is a multiple of 4, the whole thing can't be a multiple of 4 because you've got the plus 2 on the end. We know that's a multiple of 4, so you've got a multiple of 4 plus 2, which is not a multiple of 4. So hence we carry on from there. So that is the order you do these terms in. Okay, moving again onto some functions. Let's just make that the right width. Okay, so give you a couple of minutes to have a look at this question. Now, in case you hadn't realised, when you got functions, you're taking inputs and you get it, and the function creates the output. So you put a value of x in, and then f is what you get out. And what you get out is, in this case, function is what. Sorry, let's just write that out in a different way. The function is what you do to x to get the output from x, which in this case is nx plus n. Now, if you've got the outputs from program f and you want to find the number of inputs, you want to find the way backwards, which is the inverse function. So we know it's going to be one of these two answers. It's not going to be the other two answers because we want the inverse. And because it's a single x, we can use our easy way to do the flow chart. So we start off with x. Okay. And the first thing we do is we times by n to get nx. And the next thing we do is we add n to get nx plus n. So if we start with x, undo that, we get minus n to get x minus n. Then we divide by n to undo times by n to x minus n over n. So the inverse is x minus n over n, which is this one. Just to recap, the other method of doing it is to write let y equals, so you always say let because you're introducing y, equals n x over n minus n equals nx, and then divide by n, y minus n over n equals x, and we use this to create our inverse function of x minus n over n. Now, what function describes the running program of f followed by g? So let's just get f is nx. It's nx plus n, and g of x was, what was it? It was n squared plus x. So let's see if you can now do this one. I'm going to give you a minute to do this. Now you've got an idea what's going on here. Right, so if you do f followed by g, that actually means g f of x, because you're doing f first, then you do g. So we know we're not going to be this one, and we're not going to be this one. So which of these two is f followed by g? So we're going to take the f and put it in where the x is in the g. So what we get is n squared plus x, which is nx plus n from the f. Okay, so I've taken that, put it in where the x is, I get that. And we can see straight away that we've got n squared plus nx is this one here. Right, last question today. Let's give you a minute to have a look at this. Right, this is a very unusual question. So let's look, we've already got, so we're doing g followed by f is less than the number of program f followed by g. Well, we've done for f followed by g. F followed by g was, let's just write it down, f followed by g, f of x, g f of x was equal to n squared plus nx plus n. And then if we do g followed by f, g followed by f, we're going to have, what was it again? Those functions, oh there they are, sorry, I've got it in front of me. So g followed by f, we're doing that and we'll put it into there. So we're going to get n open brackets n squared plus x plus n. So we get n cubed plus nx plus n, which was that one over there. Okay, so we've got, wait, what have I written down here? So f followed by g, I want g f of x, g f x n squared. Sorry, I made a mistake here. I've written that wrong, that wrong, that wrong. It wasn't that, it was gf I wanted, so it was that. There we go. Apologies on that one. The previous one I did the right working, then ticked the wrong answer. So, okay, so we've got this, and we're saying the number of outputs produced by running the program g followed by f is less than the number of outputs followed by this. So we're looking for when this is going to be less than this. So I'm not sure what they're really trying to get at here, where the number of outputs on this one is less than the number of outputs on this one. It looks like they're trying to solve n cubed is going to be less than n squared, but it's not, I think. And then if you divide both sides by n squared, because it's a positive number, we can do that, because anything squared you get a positive number, and so therefore we can divide by that. We get n is less than 1. From that, for this to be less than this, I don't think it can be the number of outputs. It doesn't make sense. I'm sure it must mean the value of the outputs. It's getting there. Okay, so divide by n squared, you get n, divide this by n squared, we get n is less than 1.